As we look at this guy, the vertex has an x and a y, and the x is the opposite of what you see there, and it's exactly what we see there. So what's the vertex? -1 and -2. So -1, -2 is right there. Next, because this right here is positive, I know that my entire v opens upward. And the slope is this. It's 2 over 1, which means I go up 2 and right 1. But I'm also going to, I know because it's absolute value, that I'm going to go up 2 and left 1 as well. Up 2, right 1. So up 2, 0, 1, 2, right 1 puts me there. And then the next one puts me there. Now when I go up to left 1, up 2, left 1, it puts me right there. And then repeat the process here. So now we get our bounce right there. It always bounces on the vertex, and this is our equation. So three things to consider. Number one, where do we begin? Where do we begin? And we always begin here at the vertex. This tells me how much it shifts left or right, up and down. Then I need to consider the positive here. So that's number 2, because it opens upward. So that gives me the 2 directions. One is up to right 1, and the other one is up to left 1. Notice I have to go up and up. If the original slope is negative, that means it opens downward. So I would go down to right 1, down to left 1. So practicing through number 1, what is the vertex here? Good, so our vertex is the opposite of what we see there, so -1 and -1. So there we go, 2 pieces of information there. Does this open upward or downward, class? We know it opens upward, so I'm going to interpret this here as up to right 3 and up to left 3. Up to right 3, up to left 3. And there we go. So notice that because this is less than 1, the a here is between 0 and 1, we know that it is wider. So we know how it's shifted. It's shifted to the left 1 and down 1. We know that it opens upward, and we know that it is wider. In fact, we know specifically how wide it is just by doing the positive slope and the negative slope, keeping the rise going up because it opens upward. Good, so as we go backwards now, excuse me, we notice that the slope is negative, which means that it opens downward. So if I were to start writing the function, I would say y equals, I instantly know that there's a negative on the outside. Now talking about shifting. What about shifting? Well, look here. Here's the vertex at 2, 1. So how does 2, 1 fit in to inside the absolute value and outside? So we do see here that we would have to put -2 here. Whatever goes inside is opposite. And then the positive 1, the shift up 1, is positive 1 outside. Okay, so far what we have is we have the correct vertex in the right place. We have the direction saying it opens downward. The only thing we're missing is the steepness, the slope. So it doesn't really matter which slope we count because both of these slopes are the same, just one is opposite. So all we have to do is count. So from this point, which they gave to us, to this point here, I go up 1, 2, and I go right 1, 2, 3. So that slope is 2/3. Up 2, right 3. And how can we check this? All right, so when I do check a graph here, I do see that I get the exact same. I get a -2 here, or a 2, 2, 1, and a 2, 1, and a 5, -1 when I do plug it in, and it does work. All right. As we're practicing this, remember where we can start. We have a function, so we start with the y. We're going to have absolute value because I see a bounce there. And we need some things inside and outside. So tell me what goes inside, tell me what goes outside, tell me opening up, tell me opening down, tell me slope. These are the things that we need. I see that my slope here is 2. Where did that count from? From here I go up 1, 2, and right 1. So here is a 2. And since the entire thing opens upward, it's a positive 2. So all we have to do now is fill in the blanks here and here. It's plus 2 because of this. Plus 2, and you said the outside is plus 2? And the outside is plus 2. The inside that takes the opposite. So I have to change that to a minus, and this one to a minus as well. Please take a moment to graph this on your device. On the last page here, the instructions at the top say, tell whether the graph of the function opens up or down. This should take all of 15 seconds. Please do all 3 of these real quick and describe to your neighbor why. Go. Tell me for number 1, what is it? Where does it open? Up. For number 2? Down. Number 3? Up. Good. This is a positive 2/3. Negative 4 goes down, and a positive 1, which is not even written. There we go. All right, now the next part here says, identify the vertex of the graph. So just take here. Notice what we can ignore. You can ignore the 2 in the front, the negative 3 in the front as a coefficient, and the 1/5. So you're looking here and finding the vertex. Perfect. Negative 13, negative 6. How about number 4? Good. Positive 4 and negative 7. Opposite of what you see and exactly what you see. And lastly, number 6 here, please. And negative 2, positive 11. Remember, this is not just about a position. It's not just a position, it's also a description. You could say what you do to the parent function is shift the whole thing left 2 and up 11. So it can also describe a shifting and not just the vertex. So depending on the instructions. If the instructions say vertex, then do that. If it says describe how it changes, then you could say it shifts negative 2 or left 2 and up. This right here tells me it's going to be opened more, arms open wider. All right? And narrower, you could also say tighter or narrower too. All right, how about this one, class? What's the negative 8 or simply the 8 tell me? It's going to be tighter or narrower. And this one over here, we say, oh, it's a fraction, right? Ah, but it's bigger than 1 if we ignore the negative. So this one is also going to be tighter. When will it be exactly the same?
0.
Not when it's 0, but when it is, when it's 1. Good. 1 means that it would be the same. 0 would be flatlined.